beneath the vast, icy sheet of Antarctica, spanning 600 meters of solid ice, lies a profound and thrilling discovery that has left scientists astounded. While the saying, "still waters run deep," may often imply a calm hidden beneath the surface, the depths of our oceans prove anything but. Earth's waters are massive, dark, and enigmatic, filled with creatures and secrets beyond our understanding. The deepest, coldest regions of the Antarctic waters have long been thought uninhabitable, as previous studies concluded that these icy depths were too cold, dark, and nutrient-poor to sustain complex life. Yet a groundbreaking study, recently highlighted by Elon Musk, has shattered these assumptions, revealing that a resilient colony of unknown animals thrives deep beneath the ice. This life form, hidden for centuries, isn't supposed to be alive here, and yet it exists, captured on film for the first time in history. So, what exactly did researchers find, and why is this discovery stirring such a frenzy among scientists? Join us as we uncover the impossible find that reshapes our understanding of life in Earth's most extreme environments. In 1958, a U.S. submarine became the first craft to traverse under the polar ice, reaching the North Pole and marking an extraordinary achievement in scientific exploration. This mission paved the way for modern nuclear-powered submarines, which now serve as silent, long-lasting vessels capable of traversing hostile underwater terrains while remaining armed with deterrent capabilities. These submarines don't just symbolize strength and security. They also provide scientists with unparalleled access to the hidden world beneath the ice. This underwater mission, seen as a historic milestone, laid the groundwork for new scientific and military advancements, allowing scientists to gather data on the unique environment under the Arctic's frozen expanse. Antarctica, often thought of as a frozen wasteland, is far more than just Earth's coldest continent. It is a land filled with profound mysteries, both on its surface and beneath its icy waters. Beneath the remote Filchneron ice shelf, geologist James Smith from the British Antarctic Survey braved some of the world's harshest conditions. Spending 3 grueling months enduring sub-zero temperatures, Smith survived on dehydrated food and lived in a tent on the unforgiving ice. His mission was to reach seafloor sediment, buried under nearly a kilometer of solid ice, to study the geological history of the floating shelf. But the logistics alone were a Herculean task. Smith and his team had to melt 20 tons of snow to produce the 20,000 liters of boiling water needed to drill through the ice, pouring it down a borehole over 20 hours until they finally broke through the shelf. When they finally succeeded in lowering a camera to the ocean floor, they expected to see the bare, light-colored silt of the Antarctic seabed. But what the camera revealed was astonishing. Instead of a simple, barren seafloor, the video footage captured a massive, solitary boulder, unlike anything they expected to find. This boulder was not only an unusual feature in the otherwise flat seafloor landscape, but was also covered with life. Sponges, strange stalked animals, and filaments waved across its surface, clinging to it in eerie, alien-like clusters. Smith had, by a fortunate accident, drilled into a rich, isolated oasis of life, surrounded by miles of barren ice. The location of this boulder made the discovery even more perplexing. It lay 160 miles from the nearest open sea, where sunlight and potential food sources are found, and much farther from any other obvious nutrient source. According to Hugh Griffiths, another researcher from the British Antarctic Survey, organisms living under the ice shelves are usually small, mobile scavengers like fish, worms, and krill that survive on minimal resources. But this boulder supported filter-feeding species, creatures that depend on a steady flow of food particles drifting in from the open sea. This discovery flips our understanding of life in the deep sea, as we've typically believed that immobile filter feeders would not be able to survive so far from direct nutrient sources. The most pressing question is, how are these creatures surviving? The distance from open sea and sunlight is so vast that theories about typical food sources do not apply. These animals are in near total darkness and extreme cold, conditions we believed were incompatible with filter-feeding species. Yet here they are, challenging everything we thought we knew. Marine snow, organic particles that drift down from above as creatures decay or shed waste, usually provides food for deep-sea life. Around Antarctica, plankton supports small fish, which in turn feed larger marine mammals, resulting in a cycle of life and decay that feeds creatures on the ocean floor. But in this isolated pocket, so far from abundant life and sunlight, marine snow is unlikely to be sufficient. This unique habitat, hidden beneath the Antarctic ice, has triggered an array of new questions for scientists. How did these creatures even get there? What sustains them so far from nutrient sources? How long have they been living under such extreme conditions? Could they be a distinct species adapted exclusively to life beneath the ice shelves? And if the ice shelf were to collapse, what would happen to this isolated ecosystem? For now, these resilient creatures live in complete darkness, where no light penetrates, surviving in an environment where only the toughest life forms can thrive. Their existence reminds us of the adaptability of life and suggests that Earth's extreme habitats may harbor countless other undiscovered organisms. This discovery doesn't just deepen our knowledge of life on Earth. It has vast implications for understanding where and how life might exist on other planets. As we continue to probe the mysteries of Antarctica, we realize that our planet holds secrets that are only beginning to surface, and this discovery at the edge of our understanding is only the beginning. The Antarctic animals found on this particular rock face a unique and isolated existence, dependent on a mysterious food source. Unlike creatures that benefit from the constant fall of marine snow in busy waters, these animals are isolated, beneath a mile of ice, and remain permanently attached to their rocky habitat, unable to move in search of nourishment. According to researcher Hugh Griffiths, the conditions they face are particularly harsh. There's limited food, and it arrives inconsistently. So, how are these animals surviving? Researchers propose that rather than food particles falling directly from above, the sustenance these creatures need might be arriving horizontally. Current studies of the region indicate that food could be traveling through marine currents, originating from as far as 390 to 930 kilometers away, making it possible that organic material drifts across these vast distances to feed the rock-bound ecosystem. Rich Mui, curator of invertebrate zoology and geology at the California Academy of Sciences, explains that as Antarctic seawater cools, it becomes denser, sinks to the ocean floor, and spreads outward, creating powerful currents that affect ocean systems around the world. This outward flow requires incoming water to replace it, and this inflow brings organic matter across extensive distances, potentially supplying nutrients for the creatures on this isolated boulder. This nutrient flow may also introduce new species, which could impact the unique ecosystem living on the rock. However, since researchers were unable to collect physical samples, they remain uncertain about the exact diet of these sponges and other organisms. Christopher Ma, a marine biologist at the Smithsonian, points out that sponges and other ecosystems are either carnivorous or filter organic matter from the water. If these Antarctic sponges are predatory, it would indeed be a groundbreaking discovery. Killer sponges thriving in the inhospitable depths where we least expect to find life. The camera footage didn't reveal any fish or crustaceans, leaving Griffiths and his team uncertain if there are mobile species nearby, or if these immobile creatures face any threats from predators. It's unknown whether all the organisms on the rock share the same diet or possibly even nutrients, or if any wandering species contribute to this colony's food supply. Only further exploration could clarify these mysteries. Remarkably, it appears that this rock exists in a Goldilocks zone, a place with just enough food, no obvious predators, and little sediment accumulation that might otherwise bury the creatures. This favorable location is evidenced by ripples in the sediment, which are generally formed by currents, indicating that food could indeed be brought in from a distance. But the mystery deepens. How did these immobile animals originally come to inhabit this rock? They may have moved from one boulder to another within the icy waters, or they could be descendants of animals on rocks miles away, releasing eggs or larvae into the currents to drift and populate distant surfaces. With no samples to analyze, scientists can only speculate about the age of this ecosystem. Some Antarctic sponges are known for their long lifespans, suggesting that this unique ecosystem may be ancient, continually receiving new life through ocean currents over the centuries. As Elon Musk and the researchers have pointed out, it's unclear if this remarkable rock is an isolated anomaly or a more common phenomenon under Antarctica's ice shelves. If such communities are widespread, there could be vast, unexplored ecosystems hidden beneath the ice, especially since the combined area of Antarctica's floating ice shelves is about 560,000 square kilometers. Yet, scientists have explored only a space the size of a tennis court using borehole technology. This discovery marks the first-ever documentation of a hard substrate community, an ecosystem attached to a rocky surface, found deep beneath an Antarctic ice shelf. It's a fascinating reminder of the secrets still hidden in our planet's most extreme and unexplored environments. This discovery challenges previous assumptions about life's ability to survive in such extreme environments. Researchers believe this colony may be located as far as 1,500 kilometers upstream from the nearest photosynthetic source, based on local water currents. However, without the ability to collect samples, a significant challenge, they can't learn more about these mysterious organisms. Some organisms survive on nutrients from glacial melts or compounds from methane seeps, which might also be true here. Using a hot water drill, scientists uncovered an entirely new ecosystem within an underground river beneath the Larsen Ice Shelf. This hidden habitat, 500 meters below the icy surface, was found by examining a groove in satellite images, where researchers never expected to find life. Instead, they discovered tens of thousands of amphipod crustaceans, leading to a thrilling scientific revelation. Thanks to a new Southern Ocean map, scientists now have the clearest picture of Antarctica's seafloor, including the recently discovered Factrian Deep. Found in 2019, this point lies 24,400 feet, 7,437 meters, below the surface, equating to the height of 17 Empire State Buildings. Previously, scientists didn't fully understand how this region interacted with the surrounding seafloor. This new map, based on over 1,200 sonar datasets, covers a vast area of over 48 million square kilometers and could help identify seamounts or underwater mountains where marine life thrives. To better understand these creatures and their unique ecosystem, researchers must interact directly with them. But time may be running out. This habitat, beneath a half-mile of ice, faces mounting threats from global warming. Future collapse of ice shelves could destroy such distinctive ecologies. In Antarctica, Thwaites Glacier, often called the Doomsday Glacier, was observed by underwater robots, appearing to cling to the seafloor precariously. If it detaches, it may disintegrate faster than anticipated due to rapid ice loss and accelerated retreat phases in recent centuries. The glacier has carved parallel grooves into the seafloor, revealing its retreat path, and researchers warn that rising temperatures could trigger another period of rapid melting. Thank you for watching Voyager. Make sure to click the thumbnail on your screen to enjoy more incredible videos.